Hello and welcome back. Today we're going to be focusing on Module 11, the guide that talks about scatter plots, linear relationships, and correlation. We're going to start by filling in the blanks that come from page 55. A scatter plot is used to display the relationship between two what variables? Well, the only way that we can plot scatter plots, is if we have numerical data, which is quantitative. We use an ordered pair to represent the data from each individual. And the x-coordinate is the value of the input variable, which we call the explanatory variable. And the y-coordinate is the value of the output or the response variable. Remember that the response is what we are measuring. Continuing on the did I get this, each research question below describes a relationship between two quantitative variables. Which variable should be plotted on the horizontal x-axis? Well, what you need to think about here is what makes sense to explain a response that we're measuring. What are we measuring and what is our input? So how is the age of a teenager related to the number of text messages they send and receive each day? We're talking about age and the number of text messages. So if I look at the number of text messages, does that determine your age range, or does your age determine how much you text? We're going to say age is what we would have as our explanatory, and our response would be the number of text messages. Sale price of a townhouse in San Francisco, how is that related to the number of square feet? Does the square foot determine the house price, or does the house price determine the number of square feet? Well, our square footage determines our house price. For women aged 25 to 35, what is the relationship between their annual salary and the number of years of education? Does my salary determine my education, or does my education determine my salary? Okay. And lastly, is the amount of fat in a serving of cereal related to the amount of sugar? Interesting. So these are both different types of things that we're considering. They're both weighing amount of fat and sugar. Well, sugar and fat, they aren't necessarily one response and one explanatory, so it could be either in the situation depending on the question that we're asking. Continuing to learn by doing from page 56, we want to fill in the letter of the description that matches each scatter plot. What we're doing is we're looking at what the trend is here. Now, whenever I'm working with something like this that has 6 different answer types, I want to look at using a process of elimination if I'm uncertain about something. All right, the first one is X is the month, which means that on the x-axis, the lower plot would be the month. For January would be 1, so months are going this way. And then the average rainfall would be here. And Napa has rain in the winter months and months with little to no rain in the summer. Well, the summer would be in here if we're talking about on a number line being numbered 1, 2, whatever. And then we would also have winter in the later months. So we're looking for something that is low in here and higher up here, which would be scatter plot 1. Okay. B says X is the month again, and Y is the average temperature in Boston, and Boston has cold winters and hot summers. Okay, looking for the same general trend, except in this case, hot summers would be a higher temperature, because this would be rain, but now we're talking about a situation where this is going to be temperature. So we're reversing what we had before, which would be scatter plot 5. Okay. C says X is the year in increments of 5 from 70. So you're getting your, as you go from 0 on, your years are increasing. And Medicare costs. So Medicare costs have gotten bigger and bigger over time. So we're looking for an increasing trend, which scatter plot 2 and 3 are both increasing over time, and 6. So I'm looking at 2, 3, or 6 maybe. 6 doesn't really have a very definitive increase, but I might want to come back to that. X is the average temperature in Boston and the average temperature in Boston in Celsius. So we're looking at Fahrenheit to Celsius. Well, they're the same. It doesn't matter if I have one on the X and one on the Y. Their relationship is, there's a direct relationship between these two. So it should be exactly the same, which is scatter plot 3. Okay. Letter E says the chest girth and shoulder girth for a sample of men, they should also have the same relationship. You would expect a wider chest to have a wider shoulder girth. But again, so now we're not using 3 here. So C is either 2 or 6, and I would say that E is also 2 or 6. So we're going to come back to that. And F is the engine displacement and the miles per gallon. Well, bigger engine, less miles per gallon. So we're going to have a negative relationship here. That means that our answer for F is scatter plot 4. So let's go back to scatter plots 2 and 6. 2 is, this is actually an exponential curve where it starts out slowly and then increases. And 6 is kind of just all over the place. So let's see what we're looking at here for Medicare costs. Medicare costs have gotten bigger and bigger over time. There are differences. So C is going to be number 2. And that means that 6 is going to be E. Okay. Continuing, here are some scatter plots. The scatter plots show body measurements for 34 adults who are physically active. Some measurements are a girth, which is the measure of the length around a body part. Looking at this, the form of the relationship between a bicep and weight is what? So we're determining whether something is linear or not in statistics. There are not, in this class, we're concentrating just on linear. In other classes, we can focus on different types of trends, exponential trends, quadratic trends, but is it linear or not? So the form of the relationship is linear. And the association, they're asking if it's positive or negative. It's increasing from left to right, so this is positive. And for the sample of adults, which variable has a stronger relationship with weight? So which one has, like if I was to draw a line through it, which one would be closer to the line? Let's say here's my line here and here's my line here. This is closer. So we would say that bicep girth has a stronger relationship. Now we're going to make a scatter plot in StatCrunch using a certain data, and we're going to talk about a few key things that we always talk about when we're talking about scatter plots. In scatter plots, we should be talking about strength, form, and direction. Form being linear or not, and direction being positive or negative. Okay, we're in StatCrunch now, and we're going to create a scatter plot. So the first thing that we're going to do is load the data. And it's roller coaster drops. Now we're going to graph it, and we're going to make a scatter plot. So we're going to graph a scatter plot. And the x variable is going to be our explanatory variable of initial drop. And our y variable is our response, which is duration. And then we're going to go ahead and compute. Okay, and we're going to analyze this information in our notes.